Now that I've shown you how to perform a one-way ANOVA, I'm going to show you how to calculate the effect size for that ANOVA. So remember that an ANOVA tests to see if the means you are comparing are different from one another. It does not indicate how different these means are from one another. There might be a large difference between the means, or it might be small. You don't know how big it is, you just know that there is a difference. So we use effect size to estimate how large, or basically what is the size of any difference that we find. Now, I had this example in my last lecture for the one-way ANOVA. It was, researchers want to test a new anti-anxiety medication. They split participants into 3 conditions, 0, 50, and 100, and then asked them to rate their anxiety level. So we have 3 groups here, 7 participants each, and we did a one-way ANOVA on this data and came up with this F table. We rejected the null hypothesis, we found out the groups were different. You can check out the last lecture if you want to see exactly how we found that. But now that we know that the groups are different, we want to find out, are they very different? Are they just a little bit different? What is our effect size? Now when you're doing a one-way ANOVA, there are a few things you can do, but the most common measure of effect size is called eta squared. Now eta squared, written just like this, is your sum of squares between divided by your sum of squares total. So for our last example, just taking the values from the table, we would take our sum of squares between, 98.67, and divide it by our sum of squares total, 108.95. And we find an eta squared of 0.91. So that means that 91% of the total variance is accounted for by the treatment effect. Now if you remember effect size, 0.91 is huge. Almost all of the variability in this analysis came from our treatment effect. So we can conclude from this that there's a large meaningful difference between our 3 groups somewhere.